Well, thank you for joining me on this question. I'm going to be looking at question 11. This is exercise 2a. For the function y equals x cubed minus 6x squared minus 15x plus 30, and without the assistance of a calculator, find the coordinates on the y-axis. Well, the y-intercept is when x equals 0. So if we just go straight to the constant on the end, we will see that the y-intercept will be 30. But we can see that by going 0 cubed minus 6 times 0 squared minus 15 times 0 plus 30. We will get 0 minus 0 minus 0 plus 30. So 30 is the constant, that's the y-intercept. Part B, the behavior of the function as x approaches positive infinity and as x approaches negative infinity. Well, it's good to know it's a cubic, and we've got the x cubed plus ... This is the term which gives the biggest value. When x is approaching, say, negative infinity, we're going to have a negative infinity cubed, and that's going to be a very large negative value. So as x approaches negative infinity, y is going to be approaching negative infinity. So those go together. Now as x approaches positive infinity, we're going to get a positive infinity cubic plus ... which is going to be approaching a very large positive value. So y will be approaching positive infinity as x approaches positive infinity. So those go together. And so what we've got is basically what that means is in the graph, as x is approaching negative infinity, y is approaching negative infinity. And as x approaches positive infinity, y is approaching positive infinity. And we know it's crossing at 30 so far. Okay, part C. Part C is to the location and nature of turning points. Well, the turning points is when the derivative is 0. So that's the stationary or the turning points. So let's have a look. dy dx will be, we've got up here our function. And so our derivative will be 3x squared, and 2 times 6 is 12x to the power of 1, minus 15 times 1 is 15x to the power of 0, plus 30x to the power of 0 is 0. Now we let that equal to 0, and we could divide everything by 3, x squared minus 4x minus 5. Two numbers that multiply to give AC and add to give B. So AC is negative 5, B is negative 4. So negative 5 times 1 is negative 5, and negative 5 plus 1 is negative 4. So if we factorize this into a negative 5 and an x plus 1, therefore x minus 5 will be 0, or x plus 1 is equal to 0. Solving this, x will be 5, x is negative 1. So there's two stationary points. When x equals negative 1, y will equal, you have to substitute that into your function, which is x cubed minus 6x squared, x cubed minus 6x squared minus 15x plus 30. And so that would be negative 1 minus 6 plus 15 plus 30. It's 45 minus 7, so it's 38. So at negative 1, 38, there's a stationary point. And when x is 5, we put that into our equation. So it's 5 cubed minus 6 times 5 squared minus 15 times 5 plus 30. Just checking they've got that correct. Okay, so 5 cubed is 125, minus 25 sixes, 150, minus 75 plus 30. So we've got 155, take away 225, which leaves 45, 70, negative 70. So we've got a stationary point at 5, negative 70. We test those in the second derivative to see if it's positive or negative. So the second derivative, d2y dx squared, will be, there's the first derivative up here, so it's 6x minus 12. So when x is, say, negative 1, our second derivative is negative 6 minus 12 is negative 18. Since it's negative, we got a concave down curve, so it's a maximum at negative 138. And when x is 5, our second derivative, we put a 5 in 6x, 6 times 5 is 30, minus 12 is 18. It's a positive, so it's concave up. It's going to be a minimum at 5, negative 70. Something's good. Okay, and what else do we need to do? Part D, the coordinates of the point when the second derivative is 0. So that's like a point of inflection. We've got a cubic, and it's going to be a cubic. There's a point of inflection somewhere in the middle of the S-bend. So let's get that. Part D, low on power, a better charge, and its second derivative equals 0. So when 6x minus 12 equals 0, 6x equals 12, 12 over 6 is 2. Substitute 2 into the y value to find out where is that point of inflection, and we get 2 cubed minus 6 times 2 squared minus 15 times 2 plus 30. So we've got 8 minus 24 minus 30 plus 30 equals 16 negative. So at 2, negative 16, we have a point of inflection. Finally, what do they want us to do is graph this. Okay, so let's get a graph. We're going to have our y value. We're going to have our x value. And we're going to have the 0 there. And we've got negative 16. We've got 2. We've got 5. We've got negative 70 and 38. Okay. So we're going to have 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, and let's go up to, let's go up by 25s, negative 25. Okay, let's plot our points. Our first point we got was that it's going to be crossing the y-axis at 30. So we'll put a point at 30, 25, 40, 45, 50. So a point at 30. And I'll just put a little 30. Now we know it's going to be a cubic. It's turning at negative 138. Negative 138. Negative 1 is 35. That's 40. So here, negative 138. And at 5, negative 70. 5, negative 70, and it's got a point of inflection at 2, 5, 10, 15, 20, 25, 5, 10, 15. So at negative 16 here, there's a point of inflection, and it's kind of like from, did we get the x-intercepts? No, we don't know where it's crossing the x-axis. So we're going to be turning here. At that point it's turning. Okay, and it's going to be concave down all the way to there. Now it's going to be concave up all the way to that point there. And so it's going to head in that direction. That's all we know. We don't know where it crosses the x-axis. I hope this has helped. Until next time, stay happy.